Recording. Cool, that's recording. Any other questions before we begin? So we'll be just using Photoshop and Unity, and we'll be getting it working in that. Yeah, please like and subscribe. If you all want to leave a comment, please leave a comment. And just before we begin, a word from our sponsors. Cool, thank you. Oh yeah, hit that bell. Hit that bell if you want to hear any videos that show up, just so you all don't miss any of the new hot content that I'm making. Did I do that?
Some do, but they're all fake.
I actually don't even check the percentages subscribed. Stats show that only 1/10 of the people watching these videos are subscribed. So just hit that subscribe button. So what we're going to do today, we're going to be learning a little bit of like basics, like super basics, and we're going to get more into it later. But for now, just have a look at this, right? Hopefully you can see that. This is a game called Sword and Sorcery, SWORD, and Sorcery, like SWORCERY. So it's one of the first games that was released for iPad. Not the first, but is very early on the iPad, and this is when iPad was very new. So if you look at it, it's got some very basic animations that it is kind of weird. That kind of like build a lot on the world without actually that much happening. So I don't know if you can see in the background, a few of the pixels are changing color. There's a few little like floaty dust bits, or like don't know if they're dust or if they're like little flies or whatever. The dog kind of just bops up and down a little bit. The character kind of looks left and right. So there's not a huge amount going on, but it adds a lot to, adds a lot of life to the game. The trees in the back do move. One or two of them kind of bob up and down. Not all of them, but just a few of them will just kind of bob a little bit in and out. All right, so again, these are just simple little things that help a lot to make the game kind of feel a lot more realistic, a lot more immersive. Technically, this is not game feel. Game feel specifically refers to input feedback. So I do something and I get a feedback from it, whether that's visual, auditorial, particles, whatever. We will be doing some of that later as well. Technically, this is immersion, technically, but it does add to atmosphere, immersion. That'll be the kind of terms that you would use. So yeah, so the reason I show this is because like it's really simple and it literally just uses pixels, but you get quite a lot even just by pixels, primarily because of the movement, because movement draws our eyes. So as humans, we're attuned to movement. We are much better at seeing movement, and then the next thing we see is contrast, and then we start to see silhouette color details in that order. Okay, so silhouette is related to contrast because there's a high contrast around someone's silhouette. So we see movement, silhouette, color details, and we'll talk about silhouette color details later when we go to character design as well, because that's how you would design a character. You also follow those that kind of like hierarchy: silhouette first, then color, then details. But first of all, the most important thing, sorry, not the most important, but the thing we're talking about today is movement. Because no matter what your silhouette or your color or your detail, eyes always get drawn to movement. It's an evolutionary trait, right? We're trained to either see the movement of the deer that we're going to try and hunt or the tiger that's about to eat us. So that's kind of why we have that kind of like hierarchy. So first thing is movement. Oh, is that dangerous? Is that safe? Then it's silhouette because like, oh, is that thing? It's not moving, but is that dangerous or is it not? And then color, like I've identified what it is. Is it poisonous or is it not? And then details are like, okay, this one is not poisonous, but this part of it is. So you know what I mean? That's like literally evolutionary practice has affected how we view things and how we perceive things. Sound would factor into it would definitely factor into immersion. A huge part of actually a really large part of game immersion is sound, and it's often one of the parts that's most forgotten about. I am not a sound designer. So unfortunately, I'm not a great person to talk about sound. Like, I only know this is good, this is bad. I know a few things like minor notes, major notes, little small stuff like that, but I am much more of a visual designer. You can see the dog kind of bop every so often. Just a small thing. You will. You will get sound later on. So here's a little more complex ones. So this is kind of a mix. So you can see they're using like a almost like soft fuzzy. It's pixel art, but it's not quite that fuzzy. This is from Irish Darkside Detective. I already showed you some of their pics before, but here is like an example. And you can kind of see, these little lines? They're just squiggly lines that move outwards. And they have a little bit of a blur glow on them. They're just little squiggly lines. But what they do is they give the effect of electricity because they're so fast and they move so quickly and they have this kind of glow behind them as well. So it gives you this effect of like, oh, this is powerful electricity. There's something going on there, um, and it isn't very complex. It's just a line with some glow on it. And this is from Hyperlight Drifter. And if you look at all the animations in there, they're all like 3 or 4 frames. They're not very complicated. We'll talk about what frames are. So there's not that many like frames of animation. So every time you have an animation, you have a sequence of images, and each of those images is called a frame. So you can kind of see each of them have like maybe 3 or 4. So this one even only has one. This literally blinks the eyes on and off. That's all it does. If you remember from the game feel video, the juice video, sorry, it just blinks. This one has like the dog's mouth just kind of opens up and down. You probably don't even need to animate it frame by frame. You can just scale that in Unity and save that as an animation. Stuff like this, that's just like bipping back and forth. This frog is just opening back and forward. So they're all simple. Every single one of the animations you see here, they're not complex at all. They just do really basic stuff. Even the main character, the cape just goes bup bup, but it's timed to the little wind squiggle. So it feels like the wind's actually affecting things. Although we should ideally get the leaves moving as well. Maybe some of the grass. But in general, it all ties in pretty well, right? And as a whole, it makes this whole area feel like a marketplace, and it feels like it's lived in and quite lived in, like it's quite packed, even though again, not that much is actually happening. See in the left here as well. These are just little lines, small little squiggles of lines moving downwards, just make it look like the water is flowing. What was Yago's bouncy boy? Don't remember that. So speaking of bouncy, here is another version where they do like again, it's only 3 or 4. This is Cryptid and Necrodancer, but you see the way everything kind of like punches. It's like it squishes when it goes down. So there's a concept called squash and stretch. That's the main concept I want to talk about today. And you can see whenever they jump and they hit the ground, like they do an impact, they squish, and they don't just squish down. They don't just scale down. They also kind of like scale sideways. They kind of so like if you imagine if I have a stress ball, if anyone's ever held a stress ball, if I squash it in one direction, it squishes out in the other directions, right? So if I squeeze it from top to bottom, it squishes out the sides. So squash and stretch, that's the main thing we're going to deal with today. There's loads of principles of animation. These are all things called principles of animation. And we'll talk about all the rest of the principles next week. For today, our main principle is going to be squash and stretch. Yeah, 12 principles of animation are like, I mean, even if you've done animation for 20 years, like you still use them and you still need them kind of. But you can kind of see the stress ball thing on the blob monsters down there. It's really obvious in them. When they squish down, they squish sideways as well. So they like expand sideways. Um, what's that bouncy boy? That's very bouncy. So so this yeah that's the squash and stretch concept, and you can kind of see everything in this game. This is way more. Everything in this game, it's actually less animations, some of the stuff, than the previous one. But everything is moving, and that's because the whole game is built around like rhythm and bouncing, and the animations time the rhythm to the rhythm of the game. and it helps a lot. Like the heart is just expanding. It doesn't even really do that much. It's just expanding and going smaller. But it makes it really feel like the heart is like bipping up. Which purple minion? This yolk? It's got like a little hoppy thing with its leg. So the way that these are put into Unity or any game engine, if we're using 2D frames, is we use something called Sprite Sheets. And this is what a Sprite Sheet is. So it's just a series of pictures that put together create an animation. So if you look at this, it's like closed mouth and then slowly opens, 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 closes, closes, closes. And that's a Sprite Sheet. So it just kind of has a different small change each each animation. Same with here. You see like it has this kind of set animation. I don't know why there's so many of these. Is it the eyes? Do they move? Did the mouth move? I'm not quite sure. But it's this kind of like hop animation, and it's slowly changing frame by frame. This concept was discovered using a item called a zoetrope, where they like took images of a horse, loads of them. Moybridge did this, and then he set it up on this thing called a zoetrope. So if you look in one of these slits, and they would spin it really fast, and it would look like the horse is running because each frame is slightly different from the other, but they're all sequentially. But once it's fast enough, your eye can't tell the difference, and it starts to think that it's moving. So usually, this difference for a quote unquote realistic-ish movement is around 25 frames. That's why movies for a long time were 24, 25 frames, because at about 24, 25 frames, if you have motion blur as well, it kind of makes it look like it's real movement. You can't tell the difference that much. Now, why gamers talk about 60 frames, 90 frames, 144, 240, all that, like way more than 25 frames a second, has to do with multiple reasons. One is that like games by default don't have motion blur enabled, so they're like pixel perfect. So we're much better at detecting differences if it's jerky at 60 frames. And then there's all sorts of other there's all sorts of other complicated stuff we don't need to get into that's not related to visual, like input lag, like syncing. Like we're not going to talk about any of that. We're just talking about visuals. Yeah, pretty much, because they it is an optical illusion, pretty much, because yes, each image is just an image. It's just a series of images, and they're just moving really fast. That's how film works. So and like no matter what you're watching, whether it's TV, whether it's your monitor, whether anything, any movement you see is literally just a series of images. So it's just that they're going so fast that you can't tell. So yeah, it kind of is an optical illusion. So sprite sheets are kind of trying to do this. They're trying to use this illusion to make it work. However, specifically like these kind of sprite sheets, these come from like old school games, and we kind of are used to that in even modern games, especially when we're making a 2D game. It's very uncommon you see a 25 frames a second animation in games. You can see it in animation sometimes. Yeah, it's from Spelunky. Cuphead, I think, is on 12, so I think it's 12 frames a second. So even in animation, there's a concept of like on 12s or on 24s or on 1s or 2s. And I think Cuphead is 12 frames a second. I could be wrong, because a lot of the older animations were 12. Some of them are 24. And even in modern days, like it's a bit complicated nowadays because they have like extrapolation between frames, so it's not quite frame by frame anymore. But if you've ever seen the Cuphead GDC video, literally just search GDC Cuphead art in YouTube. It's pretty crazy. If it's 24, I think do. Are they 24 for the bosses though, or are they all 24? Yeah, the Spider Verse one, that is only when the main character is getting to grips with their power, and then as they get better, they move into 24, which is very cool. So they kind of go from this stuttering look into like a smoother 24 frames a second. Yeah, you don't notice. It's when he's swinging with Peter Parker. Oh wait, oh spoilers. When they're escaping the base, when they're swinging there, you start to see like he screws up a bit, and he's still on 12s, and then as he gets into the swings, it ramps up to 24. It's pretty cool. They have a lot of little things. Yeah, and at the end he's like full 24 because he's figured out how to move better. So anyway, so in games we don't usually do full 24. We even sometimes do like 10 frames a second because we're used to that happening. It's kind of a traditional thing because it came from like actual limitation. We couldn't have that many frames, but yeah, it's definitely not that high of a requirement in games, except for Cuphead. But Cuphead is trying to emulate both fighting games and OG animation. So they kind of went a bit crazy, especially with like fighting games. Everything is frame based, so your animations need to be correct. Another one is Skullgirls as well. They're kind of 2D drawn. What does hardware do to animations? I don't understand the question. Oh, generally 2D and animations are way easier to run. Way, way easier. Um, you probably could. You can run it at 1000 FPS, so it's generating the image at 1000 FPS, but the actual image only changes like 24 frames. Your movement probably updates at 1000 FPS then, but the animation it will probably update at whatever the animation speed is set at, whether it's 10 or 12 or 24, whatever. It won't. And then if it's 3D, like if it's a 3D animation, because 3D animations, or some of the modern 2D animation like Spine or Anima 2D, which we might be using, they will extrapolate at a higher frame rate because they're not frame by frame, they're extrapolated. So they're like start at this position, end at this position, and they move between them. So higher frame rate will affect it. But for what we're doing today, sprite sheets are not affected. Sprite sheets always run at the same speed. There's a lot of arguments about what the human eye is capped at. We thought it was 24, 25 for a long time, but it turns out it's 24, 25 with motion blur. So, and different people are different, right? Like I can really easily tell the difference between like 30 FPS and 60. It's super obvious. And then 60 to like 120 or 144, it's pretty obvious. But past that, like 240 is hard for me to tell. Very, very difficult. 60 to 144, I think you can tell very easily. But 144 to 240, it's like pretty tough. Yeah, but some like if I swap that monitor halfway, you might not even notice sometimes. So this video we won't play the whole thing, but this is from Brown Bag, which is an Irish studio, and it's an animation studio, and it has like this concept of stretch and squash. So that first concept is the one we're going to pay most attention to, so you can kind of see. So you see when it squishes down, the sides open up, and it stretches, and it also stretches and squashes in the direction of its movement, which is important. There's all this kind of other stuff like anticipation. So anticipation we'll do a bit of, which is like if I'm about to move somewhere, I'll kind of squish in anticipation of like moving in a direction, if that makes sense. Staging is just like composition, so like how it's laid out. This stuff we're not really doing. We're kind of doing well, we kind of are. So that's just saying like if I want to make a full animation, do I start from here and then I make the major keyframes and then fill in the blanks? We're kind of doing straight ahead. So a lot of these concepts we're not going to do too much yet. This is follow through. So like there's weight to stuff, and we'll look at that a lot more next week. And stuff doesn't stop moving straight away. And you see that like it's slow in, slow out. So it's yeah in between keyframes or tweens. And things move in arcs. So like when you're making motions, try to keep them arced because it looks prettier. And secondary actions are like extra stuff. So basically today, what we're making is secondary actions. So we're not necessarily making secondary actions on the player, but we're making like secondary animations outside of the player's animation. So we're like for today, I want to make, for example, a little squishing mushroom that just kind of bobs in the background, for example, and that just adds to like the immersion. In this case, this is like a reaction to the main action. We'll also look at that. So tweening is, if I go back to where is here? So if I do pose to pose, so what pose to pose does, go away, is literally like, okay, I'm going to start here. In the middle, I'm going to go here, and then you have the end one. So in the old days, when you were doing animation, usually like the senior would draw the main poses, and then some junior would go, okay, I need to get from here to here, and I'm going to frame by frame draw all the frames in between. So the junior would then fill it in with all this stuff. They will deal with all that. So that's called tweening or in-betweening. So it's a lot of work, basically. Again, we don't have to do as much of this because we have less frames to deal with, and also in future we'll be using extrapolation based stuff. So we don't like we'll literally go start here, and the computer will do the in between for us. We don't even need AI; it's done without AI nowadays. We'll see that later. We're just gonna do the OG method today, and then we'll do the other method later. Where were we? Secondary, we're doing timing as well. So timing is super important. Oh yeah, the poor rotoscope junior. That's the worst job probably. So timing is like how fast things move, how long things take to like recover. So like if I hit the ground from really high up, I'll probably squish for a lot longer and then pop back up. So yeah, exaggeration as well. We're going to exaggerate today. So like my mushroom is going to be super bouncy. And solid drawing is literally just like having things not be straight on, having them have like a perspective, having shading correctly, making it feel like a 3D thing. Even in 3D, you can make mistakes and make animations only happen in one plane. So these are the major concepts, but what we're messing with today mostly is the squash and stretch. So this stuff, squash and stretch, and a little bit of anticipation. A little bit. Okay. So I'll show you that. So again, as I said, in a game, sorry, we had very limited frames for a lot of our games. So you can see like these are all a bunch of different sprite sheets, and you have to do a lot in very few frames. Okay, so like this one only has 3 frames. I want to say, or is it 2? Might only be 2. Yeah, it's only 2. So it literally just goes between those 2 frames. But because it's done well, it looks like it's moving forward. It looks like it's bobbing. It's literally just 2. No, it's 3. I think. I think it's 3. It's like 1, 2, 3. Yeah, I think it's 3 frames. And then even in this one, it is moving back and forth between certain frames. So you'll see like that at the end, especially. It's very obvious. It's just going back and forth between those 2 different frames. And then even as it's moving upwards, that is the anticipation. You can see like it's holding back that power. It's like pull. It's as if he's trying to like control it, and then it comes out. That's anticipation as well, and it's like just swapping back and forth between a couple of frames each time. So what we should do for our animation, also don't make horses. Quadrupeds are difficult, but in that example I did of my bridge, the full animation uses the full the full 16 frames here. But for games, you might only take like these 4 frames, for example, and that's that 4 frames working here. And that kind of level of fidelity is okay for a game, especially depending on the style you have to do. Yes, so games are always a balancing act. You're always trying to do the most with the little you have. And again, as computers get better and better and better, we don't really need to worry about it anymore. Like for 2D, like this, you can go pretty crazy. You're just going to have a massive game. The size is going to be huge. But in terms of sprite sheets, you can get away with a lot these days. Your computer probably won't have a problem. But what you're trying to do is emulate an old school style as well. Um, and in some cases, you do have limitations. So like Cyberpunk, which we've been talking about all of today, definitely has issues, right? And Undertale has a specific style, and it definitely is following the old school style. Undertale's weird as well because it has a mix of sprite sheet animation, but it also has a mix of extrapolated animation. So the sprite sheets are swapping between frames, but they're also moving extrapolate it. So, using the computer to tween between different positions. So it's weird. Undertale's a weird one. So yeah, with games, we're always trying to run real time, and we're always trying to run at least at 60 frames. We do still use, even at the super high frame rates, especially for visual kind of fidelity, we still use this concept called smearing that comes from old school animation. So you remember what I said about like the motion blur? So a lot of the ways old animation would do stuff, and current animation would do, is do like this thing called a smear. And you would do like this kind of like smear back. Let me show you. This is from Overwatch. It's a GDC. And this is how you use smear frames even in 3D. So obviously with 2D, it's obvious you can draw a trail behind stuff. But let's see. Here we go. I think this one shows it.
There's nice timing in here.
So can you see like when it moves, it kind of almost like bends in the opposite direction, and you can see that kind of wobble that happens. That's like a fake smear frame that happens, and they set up the rig to be able to do that in 3D. So like the same concepts apply. That's why kind of like a lot of people think the animation of Overwatch is really good for those reasons. So I would definitely recommend watching that as well. Post that in design practice. So let's go back to here. So this kind of smear frames of like in the direction you movement, even if I'm going 60 frames, I'll probably still put the smear frame in there. Yeah, McCree's the funny one. So like, let's see. That's a smear frame. That's a 3D smear frame where they're like, they literally have this, but when you see it at full speed, you can't tell the difference. It just looks like a smooth fluid roll, but they are actually doing that little smear to stretch it. So that's that same concept. So again, even if you're ruling at 60, 90, whatever, for visual purposes and for a feeling of smoothness, that smear frame always adds quite a lot. So here's in Gree, another version of smearing. So like they disappear, but instead of just disappearing, they kind of like have little bits stay behind, they kind of smear back. Basically any animation has smear. Pretty much all animations, especially 2D stuff, has smear. So yeah, this is Gree or Gris or what I don't know. I think it's a French studio, so it's Gree, which means grey. Yep, like all animations. If you look at Simpsons, there's loads of them, especially the older ones are really ridiculous. And when you see them in motion, you can't tell, but it just makes the animation look a lot smoother. And here's example of like 3 or 4 frames making water look like water just by. This only has 3, I think. You can tell because this thing moves on 3. And the same concept here. So this one's slightly different. I don't think this is a frame by frame. I think this is a texture offset. So basically what we're going to do with the parallaxing, trying to move stuff left and right, the same thing happens here where it's just scrolling a texture down and just keeps scrolling downwards. So it makes that look like water. It's very subtle, but it's very nice. And there's little things here. So these, particularly like these little like dots and little small things, I wouldn't do them as sprite sheets because it's going to be huge. It's like a huge sprite sheet, and it just keeps like, and it'll have to be huge as well because it's spraying all over the place. This is something called a particle effect, and we'll get to particle effects later as well. So particle effects are something in kind of in the engine, so in Unity or in Unreal, and basically they use maths and they use kind of like curves to control the motion and movement of these little particles, each of those little particles. It's a lot easier than it's. Okay, John showed you some. That's good. So we'll go a little more into that as well. And it's a lot simpler than it sounds. It's pretty simple. That's a particle effect, for example. This is a sprite sheet. This is a sprite sheet. You can tell because it's animating perfectly, like as a loop. Same here. This is a very good sprite sheet, but it's still a sprite sheet. Timing is super important. So this is an example of like it's technically decent, but the timing is all over the place. These are moving at the right speed. This is way too slow. These are way too fast. So timing is really important to try and like, yeah, but this is fine. That one's too slow. The background's going crazy. So it just depends. You need to be careful about your timing, and that's something we're gonna work on today. Maybe. So there's a few tips and tricks in here. I'm not going to go through them, but they're like pixel art tricks. They're not really stuff that you need to know. But this is important. So like when you're making something, especially if you're trying to make a gradient, so like shadow here and lightness here, and I kind of showed you that a little bit when we did our backgrounds. Remember I made it dark and then I kind of filled in the light and I was like, oh, light's coming from top left. But I don't draw it as this is called a rim light. I don't draw it on the edge. I try to draw it in the middle so the light areas go towards the middle. If you don't believe me, like just take your arm, hold it up right now to the light, and you'll kind of see the shiny bit of the arm is kind of more towards, it's not exactly at the edge, if that makes sense. The highlight is kind of more somewhere towards the middle. Unless your arm is exactly perpendicular to the light source, which almost never is. And yes, it gives it depth. Because this looks very flat. This looks like the light's just coming from there. Here's a dark. This one looks a little better. Okay. Yeah, and then this part. This is kind of more from UI. And you can kind of see, especially in UI, everything has to be very simple to make because if you think about how logos are put into real life stuff, they need to be created by a machine, right? So a lot of machines are good at making squares or triangles and circles. So a lot of shapes are made from squares and triangles and circles, so they can be created using a CNC machine, or in manufacturing it makes it a bit easier, and also for like logo design. Yeah, I know. Yeah, the Apple design is quite well made of a logo, to be fair to it. So we'll be using those concepts. So we're going to try and make complex shapes from simple shapes. So we are going to make 2 different sprite sheets. You are gonna finish that in class. Don't worry about that. I will make mine here so you can see the concept, and it's recorded, so you should be able to follow. And I'm gonna make 2. I'm gonna make 1 different animated artifact. After that, we might take a little break, like a 5-10 minute break, and then we'll go to the. Hopefully, we'll have time to go to the scrolling animations. Sorry, scrolling parallax backgrounds. Okay, with code. I'm gonna make a mushroom, I think, unless someone has a better idea. But I think I want a little bobbing mushroom. And I'll put that into my Unity project. Rolling ball. So what I want to do with this animation is I want to have something that sits there and repeats the animation and just gives the scene life. I don't want it to move around and like, well, maybe I'll have some stuff move around, but if it's rolling, it'll probably just be code just to roll and move around. I want something that like just sits there and give a bit of life to the background. Okay. In my case, I think I'll go bouncy. I think I will. So I'm going to create new. Oof, what is that? That's pretty creepy. Yeah, I could do grass blowing in the wind. Let me do the mushroom first, and then I'll do the grass. Okay, so again, size depends on what I'm trying to make. So I'm going to do, it's always pixels though. It's always 72 pixels per inch. Oh no, what did I do? Made a mistake. So the size of my, this is like 1920 by 1080, which is what we designed before. Meaning something around here probably be like maybe 128 by 128 pixels, something like that. So let's try that. I don't know if that's too small. I'm going to unlock this so I can do 128 by 128. Cool. And I'm also, so I went over the color triangle before, but when you have the color menu, oh come on, sorry, my Photoshop is hanging. There we go. When you have the color menu, you go to like here, and you can choose. Okay, so I have this background. What I will do now is I'm going to take just a little screenshot. Just going to Windows Shift S if no one knows that shortcut. Learn it. Just going to take a little screenshot here, just to make sure whatever I'm making blends correctly. It's my Photoshop. And oops, sorry. Move that. So yeah, it's kind of like here. Okay, that's pretty good. Maybe 128 is too big, but we'll see. It's fine. So what we're going to do is we're going to, what are those things? Mini biscuits. We're going to have a little mushroom here. So I'm going to make a new layer. And I will actually group that layer. Shortcut is Control G, or you can press that little group here, because I want to make one frame and then I'm going to make another frame. I don't know why Photoshop is hanging. Go away. Okay. I actually will save. We're going to go to asset design. No, design practice. And we're going to save that as bobbing mushrooms. Okay, cool. So I want the mushrooms to be on the ground. This is going to be my ground. This is the bottom. So like nothing is going to show up below that. I'm going to want that there. And I'm going to go look for references. Mushroom game. It's going to be all Mario. Yeah, I'm pretty much going to do Mario, aren't I? This is cool. Would I do red? Red would pop a lot. Let's do red. Yeah, let's do a traditional Amanita. Maybe one of these though. One of these maybe, just to be a little different. Or these. What are we thinking? We split. Alright, let's do the bottom one. Let me take a little reference. Oh, that's huge. I'm getting quite a bit of lag, y'all, so I'm sorry if it's a bit slow. We're going to do the same as last week. Done. Ship it. Finish, y'all. Finished. Job done. So I'm going to group these and I'm going to lock them because they're my reference layer. I'm going to group this one. Why am I grouping that? That is my frame 1. This is going to be my first frame. So let's do that. I will use a textured brush, I think. Oh, come on. Why is this so slow? Is it because the 3ds Max is open? Don't save. Go away. Okay, cool. Okay, again, I'm doing the dark shapes first. And what I might do is I might separate the layers because I'm going to animate them. So I'm going to separate the base by itself. So this is going to be base. And again, same concept. Start dark, build up the light areas later. Oh, actually it should be lighter up there because it's going to be covered by the mushroom cap. So lighter down here, because up there is going to have the cap on it. I don't need to go very complicated. Should I make that a little bigger maybe? I'll make the mushrooms a bit bigger so I can scale them down later. Cool. Yeah, like design practice is design practice. You're not all going to be artists. It's just so you know the concepts. But it'd be cool if you are. Okay, that's it. Then let's do the mushroom. And I think I'm only going to do 2 layers. Yeah, I don't want to go crazy complicated. Yeah, I'll go 2. It's going to have a shape like that. Cool. And again, shift the color a little bit, pop up the lightness. Experience, but in general, just any old texture brush is fine. I'm just using a texture brush. I don't really care. And I'm being real simple and quick about it. I'm actually going to group all of these together so I can do them all at once. Let me do a blobs. It's not even that great, but whatever. I'm going to put a shadow below the blobs so they don't look. Just a little shadow. And then let's do the underside of the mushroom as a separate layer as well, just to make sure that I don't mess this up. Okay, so don't, it's not, why are you confused? So just hang on. I'm only doing the frame one, which I'm literally just making the mushroom. I'm just making extra layers because you don't need these layers. So I'll show you. I put them in a group because I just want to make sure I didn't screw up. So I'm going to copy these and I can just flatten them. So you just merge them, right click and merge. Now it's just 2 layers. And I have this one there just as a backup in case I screw up. So it's just this layer and this layer, for example. You don't need more. I just made them in different layers to be safe. Let me draw a little outline around these. Okay, oh, dang it, too much. Okay, so that's just a really simple, let me just make sure it works. Turn off that reference. Does that kind of work? It's a little high contrast. So image adjustments. Let's go to hue saturation. Drop the saturation a bit up because I'm trying to match it to the background to make sure I know it's going to be on this little grass bit in the foreground. The contrast is a little high, so I'm going to try and drop that contrast down. So I have 2 layers for 2 separate pieces because I'm going to try and animate both of those. So image adjustments, hue saturation. The color is a bit bright, so I'm going to try and drop it down. Saturation a little lower, lightness a bit higher. And you can kind of see how I'm trying to match it to the background, so it doesn't look like so obvious in the background. Does that make sense? Because before it was a bit like kind of very high contrast compared to the background. So this is frame 1. Let's get rid of the background again. Frame 1 is going to be like this. Cool. And then we're going to do frame 2. Now, because it's Photoshop, we can do things like take that whole thing and just copy the entire group. Duplicate group. Let's call that frame 2. And frame 2, so I'm going to turn off frame 1 just there. Frame 2 is where I want it to like squish. So what I can do is grab that base and I can Control T. I'm going to do a warp on it. Okay, so warp allows me to grab these handles. So I'm going to do like a squish. It's going to squish down. Hopefully it doesn't blur too much. But even if it does blur, I can just redraw the edges. Does that look like it's squished down? Yeah, kind of. Probably needs to squish a little more. Just do it normal. I can also draw this, by the way. I don't necessarily have to use the transform. I can literally just draw. And then this is going to squish as well. Oh, sorry. I need to hold shift. It's there, and I'll try to warp it. So let's see how that works. Frame 1, then frame 2 squished. Does that kind of make sense? Frame 1, frame 2 squished. Gets a little blurry because I've been warping it, but I can draw around the edges to clean them up if I want to. I'm just going to keep going ahead because I want to get to the animation part. frame 1, frame 2. And then I want it to pop back up. But this time it's going to like, so what I'm going to try and do, let me draw it in black so you can see it. What I'm trying to do, texture brush, no, come on, is, so we had the basic mushroom. Wait, why aren't you drawing? Oh, it's just really small. Rip. Dang it, it's too small here. Hold on. I'll make a new document. Yeah, I guess you could say it's motion blur. It shouldn't be though. Let's do a big document so I can draw what I'm trying to do on it. Okay, cool. So what I'm trying to do is, we got mushroom. That's frame 1. Frame 2 is squashed. And frame 3 I might make it like pop back up like that. And then that should hopefully wrap around back to this. So they just kind of bob up and down. And hopefully that works. Okay, so let's see if that does. So let's go back here. Instead of copying frame 2 though, I'm going to recopy frame 1. It's a bit confusing why I'm doing that, but it's because you see the way frame 2 is already blurred. So if I warp frame 2 again, it's going to get even more blurry. So I'm going to try to use frame 1 to warp instead, because that way it won't be as blurry if I warp it. It'll be as blurred as frame 2. Hopefully that makes sense. So now, again, Control T, holding Shift. Let's try and rotate that a bit. Ooh, maybe I should have rotated before I did that. Kind of like that. And the base, let's stretch that up as well. So let me go frame by frame again. So 1, 2, 3. Maybe it needs to be skinnier. This is a bit big. So let's just make that a bit skinnier. One, 2, 3. You can do frame by frame. You can do the same thing frame by frame, but I'm just showing you a quicker way. And I think we can go back to this. I might make one where it's, this is frame 4. 1, 2, this should be 3. And this should be 4. I might make a little recovery one where this part is, oh, frame 1, turn off, straight, because you see the way like my first frame is, it's at an angle. So I'm going to make one where it comes from like the high squish and it goes straight first, like normal but straight first, and then pops back up. So maybe I'll even squish it a teeny bit. So how do we see how those looks? So I can do that in Unity. I can just bring that to Unity and test it in Unity. It just means I need to set those frames up one by one first. Or I can test that within Photoshop. Where's my frame 4? There. By going to Window and Timeline. Boop. This little window happens here. Just put that there. If it doesn't say frame animation, it might say video timeline. In which case you need to do this little draggy down and change it to frame animation. But I can do frame animation, and this is frame 1. So frame 1, turn on frame 1. Cool. Let's do the next one. Frame 2. Turn off frame 1, turn on frame 2. Let's do the next one. Turn off frame 3 and frame 3. Next one. Turn off frame 3, turn on frame 4. Now I can press play. It's going to not work. You're going to see why. So it's really bouncy, but it's moving too fast, right? It actually works pretty well. It's a little blobby little mushroom. And you don't really tell that it's blurry because it's moving really quickly. So what we can do is slow it down. So if I grab all of these, just move all of them, and just change them to like 0.1 maybe. Let's see how that works. A bit better. Maybe 0.2. So I probably want somewhere in between those. But I know the most important thing is I know the animation works. So you can see it kind of bounces up and bounces down. Okay, it's a little, maybe a little exaggerated, but it's kind of good, so it's fine. Cool. Now, this part is a little complex. A little, not too much. So I have this animation. I can save it right now as a GIF, but Unity doesn't take GIFs. Well, it does, but you shouldn't use it as a GIF. You should use a Sprite Sheet. So I can like file, export, and I can save for web, and I can have a GIF, and I can post that into Discord if I want to. GIF, blah blah blah. Press play. Oh, look at our mushroom GIF. Save. New emoji. Bobbing mushrooms GIF. Let me go find that on the desktop. And put that into Discord. And does that work? It's processing. It's got errors, but it works. It's got a little outline, which is kind of annoying, but it works. Cool. All right, so what we need to do though is to convert this into something that works in Unity. So how do we do that? So we need to do something called a Sprite Sheet. Now technically, we can save each of these images as a single PNG. So frame 1 PNG, I'll save as frame 1 PNG. Frame 2, frame 3, frame 4, and I can do that. And then in Unity, I'll just have 4 different sprites, and I'll animate them using those 4 different sprites. However, let's try and do things the proper way, the old school way. So this is 128 by 128, my size, right? And I have 4 frames. If I wanted to fit each of those frames into a sprite sheet, how big would my sprite sheet be? So a sprite sheet that contains all those 4 frames. Knowing that each one of them is 128 by 128. Mushroom sprite sheet. So I can do 256 by 256. I can do 128 by whatever 128 by 4 is. 516. Okay, I'm going to trust only. So we're going to do width 516 just to be easier because it's just going to go sideways. But Adam is correct. We can also do like 1, 2, 3, 4, like 1, 2, 3, 4. We can do like a grid like that as well, or we can do one long grid. 1, 2, 3, 4. Sometimes when you have loads of sprites, it starts getting really long, and you may want to stack them. So you do like 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So it's up to you. Sorry, Oshin. I just glanced real quick. So it's my bad. Blame Ollie. Okay, so hopefully this is correct. All right, so first I need to save them as different sprite sheets. So just file, save as. Why, oh God. Tell me, Gabriela. All right. Anyway, mushrooms 1. Oops. Mushrooms 1. Save. And then let's go to frame 2. File. Save as. So this is kind of annoying, but you can set up Photoshop scripts to do this quickly. So it'll just like export as a series of PNGs. There's an automated. It's called batch automation. You can batch automate stuff to just save each group or each frame. File. Save as. The thing is now, Sheen, I remember your name forever as the person that I think is Ole. It's too bad there's no face, so I won't remember you when we meet IRL. Cool. So we got all 4 frames, right? That's saved. I can even close this now. And now I have my sprite sheet that I'm trying to get those 4 frames in. So there's a couple things I want to do. I want to make sure that the sprites fit exactly into the 128 by 128 grids. So what I'm going to do is view show grid. Cool. So my grid is too small. So I'm going to make sure I go to edit, preferences, guides, grids, and slices. So again, view, show the grid. If your grid's too small or too big, it may not work. So we go to edit, preferences, guides, grids, and slices. And we're going to change the grid size. All versions of Photoshop as far back as like really far back will work the same. So I have a grid line every 1 pixel. Don't want that. I want a grid line every 128 pixels because that's one of my frames. Okay. Oh, and you see? Perfect. 1 frame, 1 frame, 1 frame, 1 frame. Thank you, Oshin. That works well. And now I'm going to put in those PNGs into one. The grid just going to help me snap them in. So we're going to see that. So file, and I'm going to do a file place embedded, meaning it's saved within this this sprite sheet. So I'm going to place embedded mushroom 1. And it comes in, because it's 128, it comes in with that little bounding box. And you can see I can snap it in there. Enter. Done. File, place embedded. And just keep doing that. So again, this is kind of the old school way. With new Unity, you can just save as individual sprite sheets. Sprites. And then in Unity, you put them into a single folder, and there's like a 2D tool that you can use to build a sprite sheet automatically. Build a sprite atlas. So you can do it that way. I'm just showing you the old school way, just so you know what the concept of it is doing. Okay. So popping mushrooms tree. There's the third one. File. What was I doing? Let's place embedded. And the final bobbing mushrooms. And snap it in place. Trying to make sure it's snapped correctly. Cool. And then we're off by a bit. Oh, Oshin. That little, did you calculate correctly? Oh, Oshin. That's why I wasn't snapping correctly. Tisk tisk. Okay, that's fixed. And then we just save that as a PNG. So this is a sprite sheet by itself. Mushroom sprite sheet. Okay. And we can close Photoshop. No, I don't want to shave the BSD. Okay, let's go to side practice. And let us import that mushroom. So design practice, mushroom, and I just need that sprite sheet. Yay. It's a sprite. We're telling it, hey, you are a multiple. Remember, multiple, because we have multiple sprites. We're telling it pixels per unit is, what is it, peeps? 128, because each of them was 128, and I want each of these to be a unit. And I'm going to go to the Sprite Editor. Sure. And this is where I'm going to slice this using the cell. Let's do cell count. I can do cell size, and I can tell it 128 by 128. That'll work. I can do by cell count, and I'll say on the, I have 4 columns and 1 row. So 4 columns, 1 row, slice. Done. Apply. Done. And I have 4 sprites. What's wrong with this one? I hope that's just an artifact. We'll see. So what I need to do is animate this. So let's drag one in into, oh, that's game view or scene view. Mushroom. It's a pretty big mushroom, but whatevs. Okay, so that's just one mushroom. It won't animate. Have you all done frame by frame animations yet? No. Okay, cool. So everything I'll be slower because I know that everything is new. So there's my mushroom. Let's see what the ground is on sorting layer default. Okay, and order layer 0. So I can make my mushrooms default and layer -1, so they're always going to be behind. Oh wait, what's happening? Are the bushes and fences? Let's go to 3D mode. Okay. These are 3D meshes, so they shouldn't have a sorting layer. Let's go back to mushroom, sorting layer. Why does -1 go behind? Do I have a different layer behind there? Or one of these a sprite? Let's move them backwards a little more and see whether that's the problem. Yup. Nope. Mushroom, where are you at? Why did you go? Why did you disappear? My dear mushroom, my friend, my buddy. Why you do that? One works, so it's in front. 0. Why does -1 not work? It's going behind something, but I don't know what it's going behind. It's going behind all of them. Oh, it's not here. Oh, okay, it's going behind the trees. And the okay, it's going behind the trees and the mountains. Interesting. So trees and mountains. But they both don't have a sorting layer because they're 3D objects, which makes no sense. Maybe I need to pull them further back again? They're already miles back. Mushroom. Oops. Nope. Seems like they have a sorting layer. Weird. That's just layer. That's a physics layer. Materials. Of the mushroom. I don't know if it's the Z value though. So if I put it here and bring it like there, so that's forward, it's still behind. Okay, that's oops. Press play by accident. Oh dear. No, don't do that. Okay, go back. So that's fine. I'll figure out a different way, which is I will set this. You are going to be 0. But I will make a new layer. Add sorting layer. So instead of backgrounds, I'm going to add a layer behind platform layer just for the mushrooms. And you, mushroom, are going to be in the behind platform layer. Yay, so you're behind. Oh no. No. But behind platform is in front of backgrounds. Why is it doing that? The order in hierarchy. Ooh, it might matter. Shout. Nope, it doesn't. Oh, I put it in the grid by accident. Sorry. Nope. Oh, Unity. Let me just pause the recording. Recording back on. So I just set the ground to 1,000. And then I put the mushroom as like 1. So it's behind. Cool. So it's there. Let's put 1 here. We'll copy that later. We'll make a prefab out of this in a second. So to animate, I need a animator controller. So something called animator controller. Okay. I will make a new folder. Oops. And call that animations. And this is where all my animations will go. I'm going to create a animator controller. So mushroom controller. And what animator controllers do is they contain all the animations that something will have. In this case, my mushroom. So I could have a bouncy, I could have an idle, I could have like, if it's a moving mushroom, I could have a move, whatever. They're all contained within this animator controller. But in this case, I'm only going to do one animation. So I just can drag that on and it just goes on there. I'm going to call this mushroom decor. And it's got an animator, so it's ready to animate. Okay. You always need an animator to do animations. So the animator has a controller, and the controller controls the animations. So let's have a look at that. So I'm going to select my mushroom, make sure I'm selecting it. Window, animation, animation. And because I already have an animator, it says, okay, to begin animating, create an animation clip. If I didn't have an animator, it would say to begin animating, you need to create an animator and an animation clip. And you can just like click create and it'll automatically create one for you. You can also do that. Let's go back to sprites and just open that up. So these are my sprite sheets. So I'm going to create an animation clip. Create an animation clip. It's going to ask me what I want to call it. I'm going to save it in animations and mushroom idle underscore idle. So here I have named it. This is the animation, mushroom underscore idle, and I'm going to begin animating. Okay, so far so good. The animator goes on the object within the scene. The animation we just created here, and it's going to be saved wherever we tell it to be saved. So in my case, here's my mushroom animation. It's saved there. So what I'm going to do is I need to, let me scroll in just using the scroll wheel because I want to make frame 1, frame 2, frame 3, frame 4 different animation. I'm going to try that now. Okay, so I'm going to hit record. So it's recording my animation and I'm making sure I'm selecting mushroom decor so it knows that it's animating that. Okay, so frame 1 on mushroom, I'm just having it here so I can see it. On frame 1, your sprite is going to be that sprite. Go in there. Frame 2 is going to be that sprite. It's going to go frame 1. You see it animating there? And frame 3, it's going to go this sprite. And frame 4, it's going to have that sprite. And I can tell that it's working because if I scrub, I just click and drag here and I scrub through it, I see it working. It's pretty good. If I press play though, it's going to have the same timing problem because by default animations run at 60 frames a second. So remember I said with games they use extrapolation, but in our case we're not going to do that. There's two ways we can deal with this. I can either grab all the animations and see these handles here, just drag them out so they become slower like that. So I can do that. That's fine. And that'll still do is 60 frames a second, or I can tell it to run at a slower frames a second. So I can tell it to run at 12. That's too fast. Let's go to... That's pretty good. 6 frames, right? I think that's pretty good. Yeah, you can do that, or you can also slice by the size. It doesn't matter. It accomplishes the same thing. So now, that is the animation. Because it's the only animation I have, by default, it will play that animation. So it doesn't need to know when to play the animation because it only has one. So if I press play, my little game view should have that mushroom. Oh, look at it, bobbing away. And I can grab that and prefab it. Go to prefabs, mushroom decor. So that's a prefab. And now if I copy this, I can rotate them as well. What do you mean stole the mushroom? What are you talking about? Let's put one up here. We can even flip this. So let's do a scale of minus. So it's flipped. Goes the other way. Big one there. There's mushrooms everywhere. Okay. And again, press play. Oh. Later, if we want, we can also do a randomizing script, and because it's a prefab, we just need to put on one of them, and it'll we can tell it to apply to all of them, and we can do a randomizing script so they don't all animate the same frame, because by default they'll start at the first frame and run through. But even if they do all animate the same, it's not the worst. Ideally, though, they should all animate slightly offset so they don't all look like they're doing the same thing. Okay. Any questions so far before we take a little break and we go to do the scrolling? Yeah, I suppose they're all dancing in time with the music. But like, so let me turn that back off. So without it, it's okay. It's fine. Like they're grand. Like the scene is, it's okay. But it just feels, it's pretty, but it's kind of dead. No real movement. So when everyone was saying about happiness, it does, especially the bouncier you make it. And it depends on the style of your game, because if you're trying to be serious, you probably don't want bouncy. You probably want like more subtle movements. Well, if you want to draw individual frames, it's basically the same concept as what I did, but instead of warping, you would just draw it for each frame. You can do that as well. Same thing, really. Yeah, so exactly. With fire, you would just draw a different movement for each frame. I would suggest doing what I did at the start, which was, I sketched it out first, what I wanted the mushroom to do, and you would do the same for fire. You would sketch it out very basically, the basic shape, and then you would draw each frame individually. With fire, you can also do something called a smear. So you can use the smear tool to like kind of smudge, or smudge tool, sorry, to smudge the fire, but it will blur it as well. Cool. All right, let's take a little break there, and then I'll do that scrolling thing. Be nice to me because I'm going to be coding completely from scratch. So yeah, you can just import the script that I just posted in Discord. It's pinned, and it should allow you to affect parallax, even if you're not 100% sure how it works. But do take the time to read it, because I did comment it, so you should be able to understand, hopefully.